Hi everyone, I am Atharva from Group 132 and I will talk about our project Fake Image Detection. Our goal with this project was to develop a neural network based classifier using the SciFake dataset, which can differentiate between real and AI generated images. Our team members don't have specific experience with this task, but we have a lot of experience with machine learning in general and convolutional neural networks, and we're also familiar with the common libraries such as TensorFlow, PyTorch, and so on. Our dataset contains 120,000 images. Half of them are real images from the CIFAR 10 dataset, and half of them are AI generated images made using Stable Diffusion. It's called the SciFake dataset, and it's publicly available on Kaggle. Uh, we use the standard split for our main training purpose, and that was 70, 15, 15. Our input looks something like this. They are all 32 by 32 pixel images, each with three color channels, and our output will be a simple binary classification indicating either whether it's a real image or a AI generated image. These were our initial pre-processing steps that we had proposed and thought of, and these were the evaluation metrics. We conducted a in-depth EDA of the dataset to get a better idea about what we're working with. As you can see, the class distribution is exactly the same. It's equal. The aspect ratio of all images is the same. The pixel intensity distribution showed us that images have a much smoother channel distribution, whereas AI generated images show spikes in either the blue channel or some other channel. We also noticed that the edge pixel density of AI generated images tends to be higher than that of real images. We also did canny edge analysis and we realized that real images tend to have many more canny edges, whereas AI images might have gaps in them. For the baseline model, we decided to go with random forest because it's a very powerful classification algorithm and it works well for nonlinear data such as images. We had to do some basic data preparation on this, like flattening the images to 1D arrays so random forest could process them. We had to do standard training, testing, splits, and after that, we finally trained the model using standard training processes. And here is the result for our baseline model. We got an accuracy of about 83%, which is not too bad, but it can be improved for sure. This is the confusion matrix for that same model, and you can see that its predictions are well distributed and they're not uh, biased towards one class or the other. Finally, we decided to go with the CNN approach for our main model because random forest it has some shortcomings, mostly that it can't make use of spatial patterns or other edge patterns in the image data. So our CNN architecture looks something like this. We have four convolution layers, each with batch normalization and ReLU activation functions. We have we have max pooling layers. We are using adaptive average pooling to reduce dimensionality, and we've also added dropout to prevent overfitting. And the final output will be a binary output indicating if it's a real image or a AI image. While training the CNN model, we played around with the epochs. We went from 5 epochs to 10, 15, 30, and so on. This particular plot is from a 12 epoch run. And as we can see, the training accuracy gradually increases over the epochs. The validation accuracy also increases largely and aligns with this curve. But we observed that over about like 4 to 6 epochs, the validation accuracy starts fluctuating a bit and these are signs of overfitting, but it's nothing to measure. The fluctuations are less than 5%. Due to this overfitting observation, we decided to use a 5 epoch trained model as our final model. This is the accuracy for that model, and as you can see, the accuracy was about 95%, which is which is a significant improvement over the random forest approach. And the fact that the validation curve is closely tracking the training curve is an indication that the model is well generalized towards unseen data as well. Finally, this is the conclusion matrix side by side. As you can see, the CNN model definitely outperforms the baseline, and its predictions are still well distributed over the classes, but overall improvement is observed. These are all the references that we use, and that is all from my side. Thank you.